Hello, everyone. Welcome to another student grant presentation. It's 2023, and we're so excited to have our Rally for Barnegat Bay student grant team present to you their findings from this summer. The Student Grant Award has been going on since 2007. The Save Barnegat Bay started this program in partnership with Pete McLean, who was a biologist and conservationist, TV voice and journalist in Barnegat Bay who helped to bring osprey back to the bay. He did seagrass studies. He was a scientist and a hunter, and he was a local person that cared a ton. And it was his vision for this program that young people, undergraduates in particular, were supported in doing science on Barnegat Bay. So years later, we're still proud to host this program, and we are excited to share with you the Rally for Barnegat Bay project. Rally for Barnegat Bay has been going on for quite a few years now, and it started out, the whole reason this project ever became something was because years and years ago, student grant students were testing water quality across the Barnegat Bay and in the Toms River. And they discovered that bacteria levels were really high in particular. It wasn't just normal high, it was higher even than the standards we were used to. And so for years, student grant students who are undergraduate students have been doing research every summer under the mentorship of Dr. John Wennick. Then the Rally for Barnegat Bay project was born, where Save Barnegat Bay applied for a grant to, in fact, clean up, find and fix pathogen pollution in the Toms River water. And we mean the Toms River as in the basin that goes from downtown Toms River out to Barnegat Bay, the estuary piece of it that basically is where larger boats can move around in that water. So while the whole river is of concern, we are really focusing on the 6 towns surrounding the basin of the Toms River. So without further ado, our Rally team has done a ton of hard work to try and understand where different water quality parameters are affecting and how they're being affected by other parts and pieces of rain and tides and salt and pH and all these other things. So we encourage you to listen to the very end to hear their results. If you want to see their paper, you can go online to savebarnegatbay.org, and there we have all of the papers from this year, soon to be posted, as well as all the previous years of our student grant program. And the students themselves, their biographies, and the really amazing work they're going on to do, both what they've done already and what they're doing in the future. It's our goal to try and engage undergraduate students in the endeavor to do research, mentored, true scientific research, and we're excited to be able to fund this program each year, and we hope to see more students join us for this opportunity. Applications for student grant open in just about January every year, so we encourage you to consider what your plans are if you're a college student, undergraduate student, as a high school senior in January, or as a soon to be graduating college senior in an undergraduate career. Both and everything in between are eligible to apply for our program. We can't wait to meet all of you, and thank you so much for supporting our Rally for Barnegat Bay students.
Hello, everyone. This is the Rally for Barnegat Bay Student Grant Ambassador 2023 presentation. I'm Kyle Cousins. I'm an incoming freshman at Case Western Reserve University. I'm studying biomedical engineering, and I'm from Beachwood.
Hi, my name is Dia Joriwala. I'm going to be a rising junior at Stevens Institute of Technology studying biomedical engineering, and I'm a resident of Toms River.
Hello, I'm Erin McGrath. I am a junior at King University studying environmental science, and I am from New Egypt.
Hi everyone, I'm Bethany Sulikin. I'm a rising freshman at Princeton University studying molecular biology, and I'm a resident of Toms River. Hi everyone, I'm Brianna Sulikin, and I'm an incoming freshman at Princeton University studying chemistry, and I'm also a resident of Toms River.
Hi everyone, my name is Julia Takla. I'm a resident of Toms River, and I'm going to be studying biology at Westminster College.
Okay, So starting off with the history of Raleigh, the Raleigh for Barnegat Bay project has a very extensive history, but for the sake of this project, we'll be starting in 2019. So in 2019, under the Save Barnegat Bay Student Grant Program, a preliminary water quality assessment was done along the Toms River, and this involved 8 sites throughout Pine Beach and Ocean Gate. And what they found is that one of their sites, Jeffries Creek, had concerning and unsafe bacterial levels. In the report, they stated that they use a threshold of 200 CFU of E. coli for 100 milliliters of water, and that was their standard. And it exceeded that safety standard more than 3 times in the project. Additionally, in 2020, they extended this research and extended it to, instead of 8 sites, 11 sites throughout Pine Beach, Ocean Gate, Beachwood, Toms River, South Toms River, and Island Heights. And what they found is, again, Jeffries Creek was exceeding safe bacteria levels, but alongside that, also Beachwood Beach and Dillon's Creek, which all these 3 sites we actually studied throughout this project this year. And in 2021, this is where a lot of the community involvement for Raleigh for Bay started. And 3 of our team now, me, Brianna, and Kyle, actually were involved in this project starting this year. And we presented water quality findings along with the Save Barnegat Bay Student Grant recipients of 2021. And later on in that year, we attended a press conference and we were actually interviewed by several newspapers and like, for example, the Press of Atlantic City and also the Asbury Park Press. And in 2022, more recently, Clean Ocean Action, one of the partners of the project, they began to collect water samples using their community scientists, which they're basically volunteers, and they would collect water throughout the Toms River. And later on that year, me and my sister Brianna also advertised the importance of the Barnegat Bay at this event called Paddle for the Bay, which basically aimed to break the world record for the most canoes and kayaks on a stretch of water. And it actually was broken, and they now have the world record for that. And it basically is just this whole sense of community involvement in the project. So now we're in 2023, so what are we doing now? This summer, we had 3 objectives, and the first one was to build a comprehensive data set of various water quality parameters along the Toms River. The second was to focus on upstream sites that show likely pathogen pollution issues from earlier investigations. And the third was to enhance the Raleigh Ambassador Program, which increases awareness between the project and township and environmental projects.
Again, I'm Kyle, and I'm the ambassador for Beachwood.
Hi, I'm Dia again, and although I live in Toms River, I'm the ambassador for Berkeley and Ocean Gate this summer.
Hi, I'm Erin, and I am the ambassador of South Toms River.
I'm Bethany, and I am the ambassador for Island Heights.
Hi, I'm Brianna, and I am the ambassador for Toms River.
I'm Julia, and I'm the ambassador of Pine Beach.
So this summer, we went out between June and August to sample during 3 different types of weather. We did ambient monitoring, which is during normal weather conditions, wet weather monitoring, which is done right after a rainfall event, and upstream testing, which were additional sites added onto the project for this summer. Starting with our ambient monitoring, we sampled 28 sites over a 2-week period. So we sampled 14 sites per week, as you can see in the blue, and the 1 purple site, which was done during both ambient and upstream monitoring. And these samples were then given to Clean Ocean Action for bacteria testing. Next, we sampled 9 upstream sites, seen in red, and then again, the 1 purple site on the second 2 Mondays of each month throughout this summer. And those samples were then tested for Enterococcus here at the Save Barnegat Bay Eco Center by the team.
This is our methodology video. First, we use the YSI probe to record basic water quality quality parameters. Next, we use a sampling pole with a bottle attached to the end to collect samples of water and sampling. This is our TOC form that keeps track of our samples.
So this is a map displaying all the townships around the Toms River. So the first one, as you can see at the north end, is a predominant township, which is Toms River. The next one we have on the west is Berkeley. And then we have some small townships along the south end of the Toms River, which includes South Toms River, Beachwood, and Pine Beach. And going back to the north end, we have Island Heights, and then back to the south end, we have Ocean Gate. So to start off, we're just going to be describing some of the sites that we looked at throughout our ambient and upstream sampling. So Toms River has the most predominant sites here. There's about 15 to 20 sites along Toms River. So here on the top left corner, we have TR22, which is at an overpass at Winding River Park. The next one we have is TR15, which is located in East Dover, and this is near a residential area. And on the bottom, we have TR2, this is located at Huddy Park, which is a recreational park open to the public. So the next township, Island Heights, we sampled 2 sites for ambient monitoring and 3 sites for upstream, but these 2 photos show our ambient monitoring sites. TR10 is along Dillon's Creek. This site is actually near a lot of construction right now. It's along this neighborhood, so that was an interesting site to look at. And also TR11, this is on the actual Dillon's Creek Marina, where it's home to a lot of boats, and another interesting site to look at.
So these are the South Toms River sites. They are both off of Crab Road. TR20 is a popular fishing spot. Some of the times when we went sampling there, we would find families feeding the geese and birds, which is a good cause for concern for enterococcus. And TR3 is just down the road.
So next up, we have Beachwood. So TR4 is all the sites along Beachwood Beach, which you may know in the past has been a big hotspot for bacteria, and it's a beach that is commonly shut down because of bacteria. So you can see here on the right are all the pictures of the sites along Beachwood Beach. The last time we tested at Beachwood Beach, we actually met an individual with a tattoo that had become infected from the bacteria. So that's just one of the ways that the increase in bacteria in the Toms River is becoming a health hazard to individuals. Next sites are the yacht club sites. So these are all the sites that are just along the marina near the yacht club where the boats in Beachwood are docked.
So next we have the 3 Pine Beach sites. So TR6 is actually the Pine Beach boat ramp, which is pictured on the top left. And next you have Avon Road, which is TR7, and TR17 is actually Station Avenue, which the water there is really shallow, so it may have influenced the way the data presented itself.
Next, we have our site in Ocean Gate, which is right along Jeffries Creek, which is home to a large population of geese. And during our recent sampling events, we had actually seen many children swimming in the water, surrounded by geese, and right after a rainfall event. Lastly, we have one site in Berkeley Township, which is along Mule Road, and you can see a picture of the foliage and the shallow waters around our site.
So this is the water quality basics that we tested with our YSI throughout the summer. We tested for temperature, conductivity, salinity, and dissolved oxygen, but we mostly focus on salinity and dissolved oxygen. So salinity is the amount of salt in a water sample. Locations that are eastward are expected to have higher salinity levels. Dissolved oxygen is the amount of oxygen in a water sample. It is necessary for cellular respiration or decomposition. And we test for these because they could indicate areas of bacterial growth. with poor flushing and hypoxic and anoxic conditions.
Okay, so next we have a salinity heat map, which shows the gradient of salinity measurements in parts per thousand. So here we have two noteworthy sites. We have Long Swamp Creek and Dillon's Creek, and these sites are significant because you could see that the salinity jumps in a smaller region. So there's not so much as a gradient as the other sites, and this could indicate like low flushing and low turnover.
So to look at now dissolved oxygen along the Toms River, I want to focus on some areas that I've highlighted here in these colored boxes. So the red and orange boxes are around Huddy Park, while the blue box highlights Long Swamp Creek, as Julia mentioned. So both of these sites have lower dissolved oxygen than expected, which may indicate low turnover and low flushing, which could be grounds for bacteria. So moving on to Island Heights, there's a red box on the left that points out our upstream sampling. And what I would like to point out is that the dissolved oxygen is very low in these areas compared to the two sites along Dillon's Creek. And similarly, its salinity is actually also very low as well. It's very interesting.
So these are the South Toms River sites and the dissolved oxygen and salinity for both of them. TR20, which is at the end closer to an open body of water, has lower dissolved oxygen and salinity than TR3, which is closer to a confined area of water.
So for Beachwood, the DO in most of the sites were normal, which isn't what we'd expect given the geography and the history of bacteria that we found here. However, we did have the two sites closer to the yacht club where actually had kind of low DO, not too terribly low. It was only about 2 parts per million, but it was still pretty low.
So here there's nothing too crazy about the DO in Pine Beach. It averaged 5 to 8 milligrams per liter. And as same thing for the salinity, the variation could be attributed to the gradient as shown by the heat map previously.
Here we have our average dissolved oxygen and salinity values for Jeffries Creek and Ocean Gate. And these values were found to be pretty on par with the rest of the river, but it would be interesting to have more sites along Jeffries Creek to see the difference in how the geese are affecting the water surrounding this area. And contrary to our last site, our dissolved oxygen and salinity values were extremely low because of the location of the site. You could see in the last slide, you could see that in Ocean Gate, our site was more east towards the mouth of the river, while here in Berkeley, this site is very much more upstream and surrounded by more areas of fresh water.
So the main biotic parameter that we are testing in this project is Enterococcus. So Enterococcus is a bacteria that's commonly found in the intestines. So it's indicative of fecal matter. And the reason we test for it is because if it's found in water, it indicates that there's other bacteria that you may find in fecal matter in the water. So all these kinds of bacteria, including Enterococcus, can cause UTIs. They can cause ENT infections, which is ear, nose, and throat. It can cause skin rashes and diarrhea. So it is a serious health concern if you're finding it in large quantities in the water. So we measure Enterococcus so we can determine whether or not there's fecal matter in the water and to determine if sites along the river are safe for recreational use.
So these are the concentrates that we fill our solutions into. After being incubated for 24 hours, you can see the luminescence on the trays and the cells that contain the Enterococcus bacteria.
So our method of calculating Enterococcus calculates the most probable number of bacteria colonies. The most probable number is the number of bacteria forming units in 100 milliliters.
Wait,
So our method calculates the most probable number of bacteria colonies. So one most probable number is equivalent to the number of
What do you use to edit?
Our method calculates the most probable number of bacteria colonies. So one most probable number is equivalent to the number of colony forming units in 100 milliliters.
So this is us adding 10 milliliters of the water sample into the IV solution. Next, we add a reagent. After the reagent is added, mix the solution. Once it's mixed, you add it to a concentrate and wait for 24 hours. Next is when you can count the lit up small wells and the lit up large wells. Then use the calculated NPN sheet to find your value.
So here we have the New Jersey State Sanitary Code, which is essentially a protocol used to determine the concentration of bacteria, which is classified as harmful to human health. And the process is you obtain the sample and then you test it and you make sure it doesn't exceed the water quality standards. And if it doesn't, no action is taken. But if it does, you resample the water and then action is taken. Here to the right, you have the values. So it's 30 CFUs per 100 milliliter sample, which is a mean over 60 days. And it's 104 CFUs per 100 milliliter sample for one time.
Okay, so going off of the standard of geometric mean that Julia mentioned, we're going to be using this white circle to display the safe area of bacteria that we're going to be comparing all of our bacteria measurements too. So already here you can see one of our sites, BT1, has already exceeded the area of this red circle. So just for reference, here is that Berkeley site all the way westward of the Toms River. Next, we have TR21, again, greater than BT1, and it's up in the very northern edge of Winding River. Next, we have KTR30. As you can see, it's a very big jump if you compare it to the white circle that we're starting with. And this is one of the stormwater drains that our team went to sample on. And here is a zoom in of that map. As you can see that the stormwater drains are in a rhombus shape, and this is the most southeast. The next site we have is IH7, which is one of the 3 upstream sites we sampled in Island Heights. And next we have another one, IH11, which is westward at Triangle Park. This is a site where a lot of people go for their morning walks and also to walk their dogs. And we're going to reference the white circle again. As you can see, it's ballooning in size. The next one we have is our last upstream site at Island Heights, which is IH4. This is located along the very edge of Dillon's Creek. As you can see on the map, you don't see the edge of the water itself, but it is there. And next we have the next 3 sites that are going to be displayed are, again, the stormwater drain sites north of the Toms River and the East Dover area. So here is KTR29, which is the most eastward storm drain. Next, we have KTR28, which is the northern one. And then the most, which is our greatest one, is KTR27, which is the westward one. We're going to compare, again, if you look at the top of the circles, you can see that the white circle has been exceeded in area by 100 in size and magnitude. So that is great cause for concern.
So here you can see our upstream data from June and July, and also the beginning of August. The lowest value and the highest values of Enterococcus that we had tested for were all found on August 1st, which was consequently after a lot of rain we had from that past week. So these values might be more accurate than the rest of the values that we had found. So our lowest value was found at TR21, and this TR21 throughout the summer had been in the middle range of like the rest of the sites we had found, so not causing for as much concern as some of our other sites. Now, on the other hand, all of our KTR sites had been found to even exceed the IDEX that we were using to test from. So in the video, you had seen that by counting the number of lit up wells, we were able to use the IDEX sheet to determine how like the Enterococcus levels by matching up the number of small wells and the number of large wells. Well, these 3 sites on August 1st that are highlighted in red had exceeded the number to which the number of colonies would not even shown on the sheet. And we just wanted to note that these KTR sites were manholes of some sorts where we had people from the town of Toms River come help us open up these areas. And during one of the sampling days, we just wanted to note that the workers there had mentioned that there were breakages within the pipes. So those could be noteworthy for bacteria seeking into the Toms River. Now here's just a graph of those same values from each day sampled. You could see here that the threshold of 105 mpm put in place for 1 day sampling is exceeded by every site we tested from on each of the sampling days by a lot.
So here we have a map of the areas where we think the pollution is coming from versus where we believe that it's being collected. So the circled areas are areas where we believe that bacteria is being collected, and then the arrows are showing the direction that we believe the flow of bacteria. is coming from. So you can see on the left side of the map, those are some of the upstream sites that we sampled, and they're running down through downtown Toms River. And then we believe they're getting, there's a big collection of bacteria down in Beachwood Beach. Then on the north side of the map, you can see that collection of those four northmost sites. We think that those are the storm drain areas, and we believe that there's a big source of bacteria near those storm drains, because that's one of the upstream sites. So because we're finding large numbers there, we believe that it must be coming from that location. And then we believe that flows in the river and is collected in Ocean Gate and Pine Beach. There's two beaches, specifically in Ocean Gate and Pine Beach, that have also experienced closures, and because of the geography, it suggests that there would be low flushing there. And then we also believe that there's bacteria coming from Jeffries Creek and Dillon's Creek due to the large number of geese that have been observed, and geese fecal matter that is left there. So at the original live version of this presentation, we handed out brochures, so we'd like to share those with you now. It's just 10 ways that you personally can help the Toms River. So the first thing you can do is follow all New Jersey fertilizer laws. The most important one, in my opinion, is not to fertilize your lawn before forecasted rain, because if you just put it on your lawn right before the rain will just wash that all into the storm drains, and it'll end up in our river. Number two, always pick up after your pets for the same reason. The rain will wash it into storm drains. Do not swim in the Toms River after a rainfall event, because that's when the most bacteria will be in the Toms River. Reduce impervious cover on your properties to improve water filtration. Don't use excessive salt on icy pavement. A lot of people don't realize how much ice can be melted by salt, and they'll overestimate the amount of salt they need. Number 6, never litter. Number 7, install a rain barrel at your home. Number 8, fix vehicle leaks immediately so they don't run off. Number 9, don't clean your boat with hazardous chemicals. And number 10, wash your car at a reputable facility instead of your driveway, so all that bacteria doesn't end up in our waterways.
We just want to thank Save Barnegat Bay, Mates, and Clean Ocean Action for giving us the opportunity to be a part of this project. And thank you guys all for your time. If you have any questions about any of the towns, feel free to reach out to any of us at these following emails. Thank you.